test. Richard Juvenar said, what day is the test night again?
Should be like the 21st. Let me open a calendar. 26 should be the review, isn't it? For where is that? Schedule I gave you. All right. So, yeah, 26 is the final review where we'll look at our study guide for our final exam. Your last test on chapter 6 and 12.1 is going to be on the 21st. We are still behind a little bit. So we've got 6.5 and 6.6 and review to clean up next week. So probably this weekend I'll get you a chapter 6 and unit 12 or the chapter 12.1 in Canvas, the study guide for the chapter 6. I have not seen your final exam yet. I could post an old, they're usually pretty similar, but I'd rather wait to post a study guide until I actually see the final exam. 2 more tests. You will have your chapter 6 test and then you'll have your final exam. Okay. And I talked about it some Monday, but in case you didn't hear any of it, every time I update with MathLab and I pull grades from MathLab into Canvas, it seems to be changing grades that were 0 that were not done into a no grade, there's nothing there.
Like for 5.4, I don't know if you took it out of MathLab or if you set up as 0 and
No, 5.4 won't be counted.
Okay, it just has 0 in the grade book.
Okay, it shouldn't have a 0 in it. It shouldn't have anything in it. I will get that out of there if it's still in there. Thank you. But know that if you don't have anything in there, it will get averaged in as a 0, right? If an assignment's not done, it will get averaged in as a 0. 5.4 was coming out and it seemed like there was something else that I saw in there and I was like, that needs to come out too because that doesn't.
I think it was 5.7.
Was 5.7 in there? Okay, 5.7 will come out because we didn't do anything in 5.7. Yeah. Your final exam is online, right? The 26th will be the last time that we meet. Because you guys will, I think we need to finish before Dead Day. So, anyway, this is 12.1, elimination. We write our equations in standard form. We're looking for the same equation. When we graph 2 lines on one graph, if this is this point right there is considered the solution, right? So when I'm doing elimination, I am looking, my answer is a coordinate point. One that would give me a true for both of these, okay? And I'm going to turn them into addition problems or subtraction problems depending on which one I am looking at. So most times they're always gonna be already in standard, but if they're not, you'll write them in standard. Alright, and then we're just gonna turn it into, like I said, addition or subtraction. Now this first one, you could do either. What you're looking for to start out with, and you did these in Algebra 1 and you did these in Algebra 2, you probably did them in other places too. It's just one of those things that reoccur every year. You're looking for the coefficients of your x and y to be the same. Now on this one, they're all the same. So I can go any way I want. All of these have a coefficient of 1. So I can eliminate either x or y. My problem with solving these is 2 variables. I can't solve if I have 2 variables. So I'm going to eliminate 1. I could go after the x's. They're both positive, so I would subtract. And then I would say 1x minus 1x is eliminated. That's gone. I would say 1y minus a negative 1y is a 2y. And 8 minus 4 is a 4, right? Divide by 2, and y is equal to 2. Now, if I wanted to, instead of subtracting here, I could have added. If I would have added, I would have gotten rid of those y's. When both are the same, it's going to be up to you. It's going to be up to a little math in your head and which one you prefer to do. Now, I would have gotten rid of the y's personally because you make fewer mistakes in adding, especially like when you have minus and negative. Sometimes it just kind of goes in the wrong direction. But once I have one of them, I'm going to go back up to either of my original equations, and I'm going to plug it in and solve for my x. I have my y, so I'm going to say x plus 2. X plus y equals 8. If y is 2, then x plus 2 equals 8. Getting rid of that 2, and x is equal to 6. So my coordinate point where these two will intersect each other is going to be 6 and 2. Same sign on the same coefficient, subtract. Different sign on the same coefficient, add. That seems to be the place where people get stuck the most. So if I look at 22, I have
You said same sign on the coefficient add and different signs on the coefficient subtract?
No. Did I say it that way? Because I've done that twice now today. Opposite. You got to eliminate. Same sign, subtract. Different signs, add. You're looking to get a 0. I even wrote it wrong today. So on this one, we're going to add. because a positive 3 plus a negative 3 gives me a 0. So that's going to be my elimination. So I'm going to do this one addition. So I get a 3x. Gone. 5 plus negative 8 gives me a negative. Dividing by that 3, and x is equal to negative 1. Again, it's completely up to you as to where you plug it back in, just as long as it's an x. If you solve for x, plug in x. So negative 1 plus 3y equals 5. Adding that one, 3y equals 6. And that gives me a y is equal to 2. So my solution, which one was this? Negative 1 and 2. Sometimes we don't have the same coefficient, right? So we're going to have to use some least common multiple and some distributive property and create the same coefficient. So, what if I look at problem 27? No, that was it. Oh, okay. These are problems from last week, or from Monday, not last week. If anybody wants one of those pages too. And this is tonight's. So this time my coefficients are 2 and 4, 1 and 2. Nobody's the same, right? So I can make them, and every problem's just going to be different. You're going to have to say, okay, what can I do to make the coefficients the same? Well, 4 is a multiple of 2. So I could come here and multiply everybody by 2. If I did, then I would have 2 times 2x is 4x. And this one is actually going to come out a little bit hinky. That's all right. We got this. My 4s and my 2s have the same sign, so I'm going to subtract to cancel. This one ends up canceling everybody. Whoop, 1. But does 0 plus 0 equal 1, guys? No, that's a false statement. What is our answer when we end up with this false statement in the end? No solution. And sometimes you're going to get the same number on both sides and it's going to be infinite, right? You could still have those same solutions. One solution, no solution, and infinite. solutions. Let's try a,
I have a question. Okay, so for 27, the 4x plus 2y equals 3 was on the bottom, but you put it on the top. Does it matter? Because if it was switched, it would be negative 1, wouldn't it?
but it would still be 0 equals -1, right?
So either way would be fine.
So it'd still be false, yeah.
Okay.
Yep, it don't matter whichever way. But that's good. I like that question.
Does it matter when you're starting though?
Nope. You don't have commutative property for subtraction, but you do have for addition. It's just going to end up. It's kind of like if you have. Remember way back so many years ago for y'all, when you had two-step equations and you would have like 5x minus 8, and they would start with the answer, and the teacher probably told you go ahead and put it on the end. It's kind of like that. Okay, it's not going to change your answer in. All right, let's look at 24. What would I use here for an x? For an x term. If I just needed to put an x term in there so that my brain kept it 0, I could use 0x right here. Now, can I multiply anything times 0 to make it a 4? No. What about, can I multiply anything times 2 to make it a 5? Or a 5 into a 2? So this time, I'm actually going to have to do both. I'm going to take this 5 and I'm going to put it down here. And I'm going to take this 2 and put it up here. So now I've got 8x plus 10y negative 6, 0x minus 10y equals negative 40.
Does it need to be a negative 2x when you're multiplying? Or does it matter?
No. You mean here?
2y, yeah.
No. I mean, you could, you would change all your signs. It wouldn't, you would still end up with the same answer, but I think it would be a little more work. All right, so since I have a positive 10y and a negative 10y, I'm going to add. And I get that 8x is equal to a negative 46. Everything's coming out fractions tonight. Yay. All right, so I got dividing by 8. And that is going to give me a negative 23 over 4, or 5.75. What am I going to do with this? Plug it in. So, if I put it in right here, negative, or 4 times negative 23 over 4 plus 5y equals negative 3.
You're just causing yourself to do more work.
What if those 4s will cancel each other out, right? Still not going to get a whole number, but that wasn't going to happen. So negative 23 plus 5y equals
Yeah, because if you continue that way, it's a different answer if you use it for the other one.
yeah. That shouldn't happen, period, though. Why am I not seeing it? Did I write the problem down wrong? 4x, 5y, negative 3, negative 2y, negative 8. Well, let's do, if 2y equals negative 8, y has to equal negative 4, right?
Isn't it supposed to be negative 2y?
Yes. So that would be positive 4. Good job. All right, so then I would have 4x plus 20 equals negative 3. I'm still going to get that 23, negative 23 over 4, aren't I? Minus the 20. There was somewhere in my math was wrong on there, and I'm not sure. Divided by 4, and x is equal to 23 over 4. So my answer, 23 over 4.
I know what it was. When I used the top equation, you subtracted 3 from negative 23 when we were supposed to add 23, so it would have been
I was
5.
adding
Yeah, so it would have divided by 5, it would have been 4.
okay, all right. There's always something so simple and you just can't see it when it's. All right, let's try one more of these so teacher doesn't screw up. Which one looks? We'll stay with needing to change them both. Okay, so let's go with 25. 25. Right, everybody signed in? You can go after either one. It's gonna be up to you. If I multiplied my top by 5 and my bottom by 3, I'd be going after my x's and make them both a 15. I could do top by 4 and bottom by 6 and get rid of my y's. And again, that's gonna be completely, totally up to you. Anybody have a preference?
I'm going with changing it to 15.
Okay. So we're gonna go a 5 here and a 3 here. Yes? Make sure you hit everybody. So I've got 15x minus 30y in 10. 15x plus 12y and 3. Now, am I going to need to add or subtract? Subtract. I'm going after those x's. They have the same sign, so that's going to be a subtraction. 15 minus 15 is 0. Negative 30 minus 12 is a negative. Equals, here I go again, 7, right? Okay, so if I have 42, 7 over a negative 42 is going to give me that y is equal to a negative 1, 6, yes? All right, so I'm going to plug it in where that 6 is so that I can eliminate that one. So I'm going to say 3x minus 6 times negative 1/6. It's going to give me a 2. And they're going to eliminate each other, and the 2 negatives are going to make that a positive. Subtracting that 1 and dividing by that 3. So I've got that x is a 1/3 and y a negative 1/6. Yes? And guys, when it comes to test time on these, just kind of check yourself and go back and make sure, because I promise you one of the wrong answers, right? Same numbers that you've got all over your scratch work, same numbers you came up with, but in the wrong order. So be careful on these. What you think? Elimination okay? Okay. So we're going to talk about, let's go over those property rules real quick when it comes to our exponents. Properties of exponents from days of old. Let's put numbers in here. What if I have a to the 3rd times a to the 4th? If I'm multiplying the same base, how do I simplify with those exponents? Add them. That is a to the 7th, right? And what if I have a to the 3rd to the 4th? This time I have one power raised up to another, so I'm not gonna add them, I'm going to multiply. That gives me a to the 12th, right? And then what if I have a to the 4th over a to the 3rd? Subtracting them, that's going to give me just a. Okay. What about, well, what if I had this one the other way around? What if I had a to the 3rd over a to the 4th? And I subtracted them, I would get a to the -1, right? Well, let's expand this out. A divided by a is 1, and a divided by a is 1, and a divided by a is 1. So I have 1 over a, right? So what does a to the -1 equal, guys? That's that inverse business, right? It's still positive. That negative exponent just says inverse. One more of these. What about any number in the world raised to the 0 power 1 is always equal to a 1, right? 7,322,002 to the 0 power is just a 1, right? No matter what it is, to the 0 power is a 1. Okay, and then just one more days of old side note. How do I write the square root of x using an exponent instead of a radical? What is this the same thing as? Yes, it is. My exponent is the 1. My root is a 2. If I had the cubed root of x squared, that would be x to the 2/3, right? Just bringing back some days of old stuff that we're going to need for tonight. All right. So just like that -1 exponent, a logarithm is the inverse of an exponent, basically. When I am looking at 2 to the, well, we'll go ahead with theirs. Nine is equal to 3 squared. Right? And we call 3 the base. 2 is the exponent. And 9 is my solution, right? All right, so if I'm going to write that in its logarithm form, its equal equation, just like a to the -1 is equal to 1 over a. To write this as a logarithm, I would be saying log base 3. Your base becomes your subscript of 9 is equal to 2. My exponent now becomes my solution. Okay, when we're solving a logarithm, we're finding the exponent. Because 3 to the 2nd equals 9 is a very nice one. There's a lot of really nice ones out there. But what if you have 4 to the x is equal to 15?
Can you put the x?
Hmm?
Can you put the x as the answer? Like, it would be log 4 of 15 equals x?
Yeah. That's what we're gonna find out. Solving for, that's what the logarithm is. Solving for the exponent instead of the solution. Okay, we're reworking it. It's just the inverse equation. And to start, that's what we're gonna do. We just gotta learn how to write it back and forth. So if I had, and before I move on any further, if you do not say, this is the natural log, if there is no base in it, if I say the natural log of 8, then the subscript that they don't show you is E every time. If they use log of 8 and they don't write a subscript here, it's going to be 10. Okay? That's what your calculator, if there's most of our problems, there's going to be a number down in there. But if there's not, you got to know that it's a 10. If it's ln and there's no number there, you got to know that there's an E right there. You have to know that there is a 10 right there. Okay? It's one of those that sometimes the problem is not to have one there. And if you're using your calculator, it's using the 10. And we'll look at that when we get deeper into 6. All right, so let's get a couple. I have 3 to the x is equal to 4.6. What would that look like as a logarithmic equation, guys? My base becomes my subscript of 4.6. It's always equal to the exponent. Always equal to the exponent. So if I have e to the x is equal to 8, then I have ln, remember, now writing that e in there with the ln, it's kind of like putting the 1 in front of the variable. Is it needed? No. You know that there's a 1 there, right? You do not need that e there. You need to know that that e is there. Okay? Now, if you wrote it there, would I mark it wrong? Of course not. You know, I mean, it's just there. Okay, so going back the other direction, what if I have log base 2 of 8 equals 3? Write that in its exponential form. What we got? 2 to the third power, the base, the exponent, and the solution. Yes? Natural log 4 is equal to x. What you think?
Exactly.
All right, so we're going to use some, this is just going to take a little bit of practice. and you'll get real used to that real quick. We're gonna use those properties we wrote down just a minute ago and solve some of these equations. All right, now how do I solve an exponential equation? A log equation. One, I write it as an exponent. I'm gonna set it equal to x. So I'm looking at 27. I have log base 2 of 1 equals x. And I'm just going to write it as an exponent. What would this look like as an exponent? 2 to the x equals 1. Well, if it's equal to 1, what does that exponent have to be? 0. X has to be 0, right? Because that's the only exponent that you ever end up with a 1. One we didn't talk, I should have mentioned this when we were talking about those properties. What if these two guys are the same? What does x have to be? What would that look like in exponential form? 8 to the x is equal to what's the only exponent I could raise that to that it would just stay the same? 1. X has to equal 1. Let's go after one of those problems from Monday night. Did y'all log in Monday night? How'd you do on these 3? It's just fabulous. They're so easy. Let's check out 75. This is from 6-3. And I have 8 to the x to the negative x plus 11. Got to get those bases the same, right? Both of those bases could be written as, what you think? 8 is 2 to the 3rd, right? What about 16? 2 to the 4th? Got to get the same base. What do? We talked about just a little bit ago, when you have one power raised to another power. Multiply. And since I have the same base, I can set my exponents equal to each other, right? This is allowing me to say 3 times negative x plus 11 equals 4 times 2x. Got to distribute negative 3x plus 33 is equal to 8x. Add that 3x to both sides. And 33 is equal to 11x. And x is equal to 3. Same base, guys. Got to make those bases equal to each other. It's kind of like, I think we said this the other night. If I say 3 plus 4 is 7 and 2 plus 5 is 7, If they both equal 7, they both have to equal each other, right? I mean, there's just no other. 2 plus 5 has to equal 3 plus 4. Well, if my bases are the same, then the exponents have to be equal to each other. If the bases equal each other, the exponents equal each other. So we need that in some of these problems. What if I'm looking at 31? And I need to solve this. I need to know what value is that equal to. So I'm going to write it as my exponential form. 1/5 to the x is equal to 125. I need to make those bases the same, right? So could I get that 125 to a 1/5? I'm going to take a couple of steps. First of all, how about just a 5? 125 would be the same as 5 to the, little bit less. 5 to the 3rd. Look, missing an x. Now I got to flip it over. What made my a into 1/a? A negative. So I could say 1/5 to the x is equal to 1/5 to the -3. Yes? No?
Wouldn't it be 5 to the -3 and then you switch it?
No, because a negative exponent flips its.
Well, then you have to do the reciprocal.
This has to be the same thing.
So 1/5 to the -3 equals 5 to the 3rd.
Yes. Okay. We need that practice too. If we have a calculator with us, we should do 1/5 and -3. Test that stuff out, because the first time we're playing with those exponent buttons on our calculator, we don't want to be sitting in front of our test, right?
Question.
Mm-hmm.
With the calculator, how do you put it in? Because when it has log.
What do you have? Now, don't do the log. If you have a problem that's not a 10, your calculator is doing all of those problems as a base 10. And when we get into 6.5, we're going to talk about a change of base theorem, so you can use your calculator, but you'll be using your cat button for your exponents. But you can't punch this into the calculator as it stands.
So in order to use the calculator, you have to switch it to the other equation.
Yeah, you're going to have to switch it to something else. But now if you put that in and see if you get that 125. And because my bases are the same now, right? I have 1/5 and 1/5. So now I have a value for x. Since my bases are the same, x is equal to a -3. Okay, got to make those bases the same. Let's look at about 34. What base? Now 34 you could actually put in there into your calculator. What base are they using on 34? When there's no number there, 10, right? This is Now, because that's a 10, you could use your calculator. You could say log. I think you'd have to put your cubed root of 100 in first, then hit your log button. Most of them, you have to put your number in, then hit the log button. All right, so this is equal to x. So as an exponent, what would that look like? Ten to the x is equal to the cubed root of 100. I got to get that cubed root of 100 into a 10. How do I write a radical with an exponent? Instead of saying the cubed root of 100, I could say 100 to the, 10 to the x is equal to 100 to the 1/3. All right, now what about that 100? Can I change that 100 into a 10? 10 to the second power, 10 to the x, 10 to the second, to the 1/3. Look back at our paper from the beginning. Power to a power. What do I do with those? Multiply. So 10 to the x is equal to 10 to the 2/3. And that gives me that x is equal to 1 more of these. The natural log of e to the 3rd power is equal to x. Don't overwork it. All right, what's my base on this one? So e to the x is equal to e to the 3rd. So x equals 3, right? What you think on these? One of the things that we just never did a lot of while we were in high school or in Algebra 1 or Algebra 2 is rewriting those exponents, those radicals as exponents. So that does take a little bit of time and practice. All right, now in some of these, we might not get an exact answer, but actually I think we do on it. But we're going to do the same procedure. It's a logarithm equation. We're going to solve it by writing it as an exponential equation. Okay, so if I'm looking at 89, I have 3 of x equals 2. As an exponent, I have 3 to the second equals x, and x is equal to 9. Right? Five to the third is equal to x. X is equal to, whoa, sorry. Alright, so let's get some, how about 92? And once you get them rewritten, guys, you're back in chapter 1, solving equations. I have log base 3 of 3x minus 2 equals 2. Three to the second equals 3x minus 2. So 3x minus 2 is equal to 9. Right?
Do you have to solve after that, or do you leave it like that?
No, you'll solve it. It'll give you an option for x. So, 11 thirds, add that 2. 11 divide by that 3. And my answer is 11 thirds. Once you get it written in its exponential form, it's just solving equations. It's rewriting things as an exponent that we got to get to. How about 243 is 2x plus 1? That 2x plus 1 is your exponent, guys. When you get to these problems, if you just do not know how to break this one down. Put this in your calculator and start dividing it by this one. And now, because the problem is always gonna be set up for you to get the same base, right? So we know that this 243 is gonna become a 3. And I'm gonna have 3 to the 2x plus 1 equals 3 to the 5th power. And then that is 2x plus 1 equals 5. Right? Subtracting your 1, dividing by your 2. Two x is 4, and x is 2. Alright, and just like any other, and I haven't done it, I should have been doing it earlier. If x is 2, then you have 3 to the 2 times 2 plus 1, which is 3 to the 5th. 2, 3, 4, 5, 9, 81 times 3. Just like every equation you have ever solved, you can always plug your answers back in, right? And make sure that you have the right answer. Okay? Questions? No? We're good? Okay.